Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on molarity. In our last lesson, we learned about Henry's law and the effect that pressure has on the solubility of gases. Over the last few lessons, you have learned about the mass percentage, ppm and ppb, of solutes. You have also learned about mole fraction. In today's lesson, we will define molarity. We will examine the preparation of molar solution of different substances, and we will learn how to calculate the molarity of a solution from given information. Molarity, or molar concentration, is the number of moles of solute in 1 liter of solution. It is another way of expressing the concentration of solute in a solvent. A solution that has a concentration of 1 mole per liter can also be denoted as 1 molar. Students, it is important that we do not confuse moles with molarity. Please explain the difference between these two terms now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. Were you able to describe the difference between moles and molarity? Let us go through the two definitions together. Moles measure the amount or quantity of a substance in a solution, whereas molarity measures the concentration of that substance. For example, if you were given the information that the concentration of a solution is 0.1 m, that would mean that for every liter of solution, there is 0.1 mole of substance. Molarity can be determined using this equation. Molarity is equal to the number of moles of a solute divided by the volume of the solution in liters. However, in order to do that, you must first determine the number of moles of a solute. To do this, you divide the mass of the solute by the molar mass of the solute. Therefore, molarity is equal to the mass of a solute divided by the molar mass of a solute times the volume of the solution. Let us go through an example together. We will determine the molar concentration of a solution that contains 16.0 grams of methanol in 200 milliliters of solution. Students, what do we know that will help us figure out this question? We know that the mass of the solute is 16 grams. We also know that the volume of the solution is 200 milliliters, and that the molar mass of methanol is 32 grams per mole. We will now use this information to determine the molarity of the solution. In order to determine the molarity of the solution, we must divide the mass of the methanol by the molar mass of methanol multiplied by the volume of the solution. Thus, we divide 16 grams by 32 grams per mole times 0.20 liters. This gives us 2.50 moles per liter, or a molarity of 2.50. Students, now that we have worked through one question together, you are ready to try one on your own. 12.3 grams of sodium chloride is dissolved in 500 milliliters of solution. The molar mass of sodium chloride is 58.443 grams per mole. What is the molarity of the solution?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. I hope that you did not find that activity to be too difficult. Let us work through the answer together. We know that the mass of the sodium chloride is 12.3 grams. We also know that the volume of the solution is 500 milliliters, and the molar mass of sodium chloride is 58.443 grams per mole. Therefore, we divide 12.3 grams by 58.443 grams per mole multiplied by 0.5 liters. This gives us our answer, which is approximately 0.42 moles per liter, or a molarity of 0.42. If you got that answer as well, great work. If you did not, please review your notes and try the activity again after this lesson. Let us do one more activity together. How many grams of potassium dichromate are required to prepare a 250 milliliter solution that has a molarity of 2.16? We know that the volume of the solution is 250 milliliters, or 0.250 liters. We also know that the molarity of the solution is 2.16, and the molar mass of potassium dichromate is 294 grams per mole. In order to find the mass of potassium dichromate, we need to multiply the molarity by the molar mass of potassium dichromate by the volume of the solution in liters. This gives us the answer 159 grams of potassium dichromate. Today, we learned about molarity. We learned that molarity is different than moles, and that these terms must not be confused with one another. Moles measure the amount or quantity of a substance. In contrast, molarity measures the concentration of that substance. We also learned how to solve the molarity of different substances, as well as the mass of different substances in a solution. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.